Good evening, everyone. Welcome to the Raise Dev Hacktoberfest Help Desk. My name is Joe, and I am not your host tonight. We'll be joined by our founder, John, who will host the show tonight. If you are new to the show, this is your place to get tips and tricks to complete your Hacktoberfest PRs. We're showing new projects, new ways to contribute to those projects, skills that you need to be successful in open source, and that is definitely what we've got coming at you tonight. We're going to be talking about all things CI/CD, and I'll leave John and our special guest to introduce that to you in just a moment. Before we do that, a couple of little house administrivia, things to know, things to note. As I said, we are here to help you, which means the chat is all yours. Ask any questions you want. Ask questions about what we're speaking about. Ask questions about things we're not speaking about. Whatever it is, we will make sure we try and get you an answer before the end of the show. So please bring us your questions. Our guest and our host will be super excited to see them. Other than that, if you want to post the other thing about chat, if you want to post any links or anything like that, you're very welcome to share things you're working on, share resources with each other. That's great. Just do be advised, we do have a moderation bot running in chat because we get spam. And so if you want to post a link, just do me a favor, mention me in chat, @RaiseDevs, and I will add you to the permit list so that you do not get yourself a tasty timeout. So that is all for chat. Next up, this is our last show for today, but we are live 3 times a day throughout Hacktoberfest, which means there is 2 days left to go after this, Thursday and Friday. I cannot believe it's nearly at the end, folks. We're almost at 60 shows now. You can catch our last 6 shows, the schedule for our last 2 days, at twitch.tv/RaiseDevs schedule. Stick around at the end of the show and I'll give you a little teaser of what we've got going on tomorrow and Friday, who we've got coming on, what we're going to be talking about, that kind of thing. So stay around at the end of the show for that. And if you want notifications when we go live, because 3 shows a day is a lot to keep track of, you can drop us a follow, hit the love heart, hit the little bell, and that'll get you set up for those. You don't have to keep track of our shows. The computers will do that for you. So last thing from me before I get out of the way and leave our host and our guest to have a great time. If you haven't heard of Raise.dev before, or you're not already signed up, we are a service to help you level up in your developer career, whether you're trying to get your first developer job after a career change or a boot camp, or you're trying to get the experience you need to get a promotion, get a raise, any of that good stuff. We have expert coaches who have done it before, who have been in industry, who have got that experience that's so hard to get from universities or boot camps, those kind of situations. And they want to share it with you. They want to pair program with you. They want to work with you towards your goals, and you can sign up to our service to meet them and to work with them. And we are completely free whilst you're in early access. You get to meet a match with a coach completely for free today at raise.dev. So that is everything from me. I'm now going to get out of the way and join Jarl in chat. But for now, let me add on our host for the day. Please welcome John to the stage. Hello, John. How you doing?
Hey, Joe. How you doing?
I'm doing very well. Let me also give you Angel, our guest for the day. Welcome, Angel. And over to you.
Hello. Hi, Joe and John. JJ.
Yeah. Hey, how's it going, Angel?
Great. How you doing?
I'm doing all right. So first thing I noticed, I see your shirt, Philly Code Fest. Are you based in Philly?
So I'm outside of Philly, like 15 minutes in Jersey. So I'm a Jersey boy. Cool. Can't really.
I'm also from Jersey. So.
Oh yeah. Well, we met. I remember. I don't know if you remember, but we met a few times. But I actually, the first time I kind of saw you was at a. The second time I saw you, first time I saw you was you were giving a quick Twilio demo.
Oh yeah,
at a hackathon. I think were you fairly new to Twilio back then?
I mean, that was probably like very, very early on.
Yeah, you were younger.
Oh yeah, that was. I mean, it was like well over 10 years ago. It was probably like.
Oh yeah, it was way yeah. But then the second time I saw you, I don't know if you remember, I was working in the federal government and you were doing a presentation at for the Fed Scoop down at the museum.
Oh, I remember that. Yeah.
Yeah. So like I was actually running like tons of infrastructure back then. And I was like, wow, I remembered you. I mean, from the hackathons and stuff. We have mutual friends in that space. So.
Cool. So it's been a couple of intersections. Thank you so much for being a guest. It's great to have you.
Oh no, my pleasure, man. This is my jam, right? This is what I love to do. Similar to what you guys are up to. So yeah, let's have some fun.
So before we get started on CI and all the cool technical stuff, maybe you can just share a little bit about you and like what you're up to, kind of what your background is as a developer. As you know, like Raise.dev, we're here to help people advance their developer careers. And something that I find is really valuable is talking about our stories as developers and helping people understand that it's not just a textbook story of like go to school, do a 4-year CS degree, get a job. Like there's a lot of different paths you can take, and so I'd love to hear about your path to becoming a developer. And, kind of what you're up to now.
Yeah, so I'm a little bit longer in the tooth than you, probably a lot longer in the tooth. But I started my career off in the military, pretty much. So prior to that, though, in the late 80s, early 90s, I was very young, working with whatever computers I could get my hands on. Was at the time my family, just working class family. My mother and father had 3 kids, 2 siblings, and there wasn't a lot of cash to spare on things. So, but my mother had the foresight to purchase a computer for us. She didn't even know, what it was. Nobody really knew, but bam, there was a Franklin. I can't remember the model number. It was a Franklin computer, floppy disk.
You know what the need was?
No, I don't remember. Unfortunately, I just it was at the time, like I got another one that was kind of donated to me. But anyway, I latched onto that thing and just used the hell out of it. Wanted to learn everything about it, but we had Atari 2600s back then too, and ColecoVision. So that was kind of my exposure. And coming from a Latino family, it's back then that was like unusual. It was unheard of that, you had even the Atari. Right. Yeah. So, but yeah, once I got my hands on that thing, I just really enjoyed, making it. I think the most interesting thing for me was making it bend to my will, right? Like I can type these things in and make that screen just print the number 100 times, whatever, right? That was pretty interesting. Little basic applications and stuff. And then, I don't know. I grew up in Trenton, New Jersey, which is really a really rough town. So, and around a lot of urban individuals, as far as like just we're all into hip hop and break dancing on the street corner. So, my friends weren't really, they didn't have computers, so I couldn't really share that excitement with them. And back then, there was some shaming, right? Cool? Like, well, you know what I mean? There was shaming, right? Like, I mean, this was the era of movies like Revenge of the Nerds, right? Like things like that. So, but definitely not cool. So I kind of like in my teens, I was kind of like a closet hacker, I guess, like, just working on things on my own. And back then we didn't have the internet. So what I used to do is go into like the local deli bodega on the corner and, I had a buddy who was pretty good at lifting things, and we would steal a computer, whatever it was, Wired or something back then. I don't remember the computer magazines, but they would have programs and you could just type them out. So we would type out, like spend days, 3 or 4 days, just taking turns typing this code that was on these pages and making it work. And it was like, oh, great. And then we would take it and put it back into the store. I give it back.
So I've heard these stories about people like typing the programs back in the early days. I was a little bit after that. My experience was like using the 56K dial-up modem to like try to download 100 zip files to pirate software. But, Similar kind of story, but yeah.
So that was later. But right after that, that was kind of like, getting those programs and then modems came on board. So I don't know if you know this, but in Trenton, New Jersey, there was a Trenton Computer Club which rivaled the homebrew club in the West Coast. So like they were the biggest one and we were the second biggest. And I was really young going to it was all adults, right? These people, there was no way a 13, 14-year-old was going to have money to spend on a computer. So we would lug literally these heavy ass computers to these places and just have like hackathons, right? Like they were but mainly it was all just getting your hardware working. But that's where I first like got a modem that some other gentleman was like, I don't need this. You guys want it? I can't even remember. It was like it's a kilobits, right? It wasn't even so slow. But then,
baud or whatever, 5,000 baud or whatever it was. Like,
Well, it was 20. I did 2.4. Like it was really slow. And so once we got that working, then the whole world kind of, like, wow, that was amazing. All these things, and opened up my eyes to a lot of things. And then, time moved on. In my teens, I wasn't that much into the computer scene anymore. But then I joined the military, and my first station was Cape Canaveral Air Force Station. So that's like a technology hub in the early 90s, right? Like you just had
the space shuttles, right?
Yeah, basically, I was thrown into like help working in operations for space lift, launching rockets and manned and unmanned. So back then we had the shuttle. So literally, got to meet tons of interesting people. But during that career in the military, I was actually doing a lot of internal kind of automation, right? So there's tons of systems and different applications, and right, they all kind of had their own little units, but I was surrounded by just really, really smart computer scientists for the most part. And there was no lack of mentorship. Like if you're interested in learning how to code, boom, and at that point, like I said, I had some basic under my belt. And when I first got there as a young airman, there was when you launch a rocket or any kind of any kind of missile, literally, you have to clear airspace, right? You have to clear the sea. And that was what our unit did. Was we were called the range squadron. So we had to make sure that everything was, as a support function, everything was clear so that nothing would obstruct the flight. And what happened was they had these simulations that they were doing, to kind of train us and actually just, sim the operation. But what happened was they had these simulations that were kind of preset, and when they were training folks, literally injecting data into this monitoring system, which is basically a radar system, right? And so everything was in 80 character lines of code, right? It's the old COBOL type stuff, right? So, and there was no way to kind of create new sims without having to know that, these are really old systems, legacy. So when I came on the scene, one of the things I wanted to do was I learned how to use Visual Basic from Microsoft, and back then, kind of the desktop was taking over Windows 3.1.1 at the time we were using. So I built a simulator. So graphically, right, people could create these simulations, then run them on a laptop or whatever, or actually a desktop. And it was a flight simulator, so it would just mimic the screen, look like the radar scope, and then people can create these scenarios and then run them. So you could just run like a training script, build it out visually, and not have to inject into the real system, because there was you have to schedule some offline time to make sure that the system wasn't reported, because that was a live system. So you didn't want to inject into that live system. So that was one of the first projects, and they really liked it because people were like, then a lot of folks that were not really good at their job were kind of exposed because of that software. So that was like my first big project. But again, right, like I already knew Basic, and then Visual Basic kind of came, and they are different, but it wasn't that much a syntax, right? It wasn't that bad. And then after doing all that, there was other projects that I did. But again, that wasn't my main job. My main job was, I was in operations. So literally briefing air crews on coordinating air support, the sea support. Right? I was one of the people.
I hear this kind of story all the time from people where it's like, I have a job that's X, like computers could help my job better, make good chunks of my job or make things easier, and so they get into coding and they apply it to whatever it is they're doing that's not like coding related, and they're seen as like a wizard to everybody else. Everybody else is like, oh my god, like you just like saved us all so much time, and this is like the massive utility of programming.
I would agree with that. Like that did happen to me post NASA, right? Like or post Cape, because there was so many. Like, they were like, "Oh, that's nice."
Yeah, exactly. You're like surrounded by computer scientists, right? But like,
there was a time I remember we just got a new printer. The unit got a new printer, and I don't know. We were connecting it to. They had Sun Solaris boxes back then. Like they were just coming on the scene. And I remember I was trying to get this printer to work, connected. It was like, can't get it to work. And one of the the guys there was like, "Oh, you need a driver." And I'm like, "Okay." And I looked like, for a day trying to find a driver for Sun. And he goes, No. You got to write your driver. They don't have that. They don't have drivers for that. And I'm like, how do I even like begin to do that? And he goes, it's easy. And he showed me a few things in assembler. And he did most of the work, but then he was like, you got to figure out the rest of the bits. And then like literally I wrote a driver, right? And it worked for what we what we were using it for. So that was like even more eye-opening. Like, wow, it's not that difficult, right? I was a little worried, like, how am I going to get this done? But yeah, so those are the kind of things that those people in that that situation they're not impressed real easily, right? Like there are innovations you can make, but in general they're the innovators. So you're like just like wow in all of them. But then post the military, I was working in startups. And then came back to the U.S. and I started working in the federal government. But during that time I was in startups, I was actually working on that's when the kind of internet kind of boomed, and we were doing one of the main products I was doing was a content management system. So think of WordPress, but like back in the day, written in ASP.NET or ASP, I should say, like version one.
Before ASP.NET.
Right, exactly. And then that was the upgrade, right? We're doing ASP.NET now, so we can support that. That was one of the products that we supported. And that back then I was in Iceland actually. And I know there's probably a couple gamers listening to this or watching this, but the game EVE Online, they were literally down the street from our office, and we were pretty tight with them for a while. And I remember the early stages of them building that game, in that platform, which is like I'm still amazed it's around today. But they just had at the time when I heard them, pitch the ideas and tell me about it. I was like, wow, that's amazing. Like it just blew my mind, like their whole vision for gaming, and it's coming to life. Like it's still around. It came to life and it's still here, and it's really popular still. It's amazing.
You said you did some startups before you went back to the government?
So
what was the startup situation?
So when I left the military, I kind of glanced over that. I left the military. I moved to Iceland, and I was leaving the service, and basically just relocated to Iceland. And then from there, I was working for the air defense system. Doing the work that I was doing, kind of continuing that work over there, helping them for NATO, a contractor for NATO. And then, I just felt like, all right, enough of the military stuff, and wanted to jump into some more innovative things, working in the internet technologies. And I got a gig working for them. I was initially managing their infrastructure because I had a ton of experience from the previous stuff I was doing in the government. And then I started actually hacking on some of the product as well. A lot of front end things, and it was very interesting. I learned a lot, and it's funny because a lot of the technology problems we still have today, we had back then as well, just kind of in different stacks now. So it's being in this business so long. It's funny when you see a problem that you saw 20 years ago, 25 years ago.
What's old is new, right? Like I mean, there's always this thing about like concurrency or some other doing functional programming, for example. Like it becomes
well,
it's like, well, functional programming has been around forever. It's not a new thing. It's just like
in a different stack, right? That's what I always say. It's like I've seen this before.
Invent something new.
Right. Like when I see problems or I'm involved in trying to help fix problems, like I've seen this before, but in a different technology, like it was C++ or some other Java, but now it's in Go or what's the Scala.
What are you up to now?
So
like what kind of engineer are you? Working front end stuff, back end? Like what's your
so I like just real quick, I kicked around and like I said in the startup world in Europe, Iceland for a while, and then I came back to the US, and then I worked for the federal government in many different agencies and different roles, but always kind of doing a couple things, which was bringing the government, I always wanted to bring government into kind of the future, right? Because back then it was just like they just had really old technology. Nothing was really updated, and for proper reasons, right? Sometimes the systems just are so critical you don't want to make a change. But I was always, a proponent of open source within the government, and I got so much pushback from so many people. And a lot of it was just, I think they just didn't understand, what this open source thing was. And back then, you got to remember, the industry was just like completely dominated by software vendors, right? Like if you didn't buy this software, proprietary stuff, right? It wasn't open. You just bought it. You paid someone, they gave you a CD or some access to download some files, and then that's how you got your software. It isn't like today where you can just go do a search on GitHub for whatever, and you may find some, stuff to get you started. So I've always, when I saw like I would say the amount of domination that those vendors had, I was just like, wow. And this is not good. Like there's so many other tools that we could use and we can modify it. That was the main thing that I really liked about it, was so I could get like this core functionality that I needed. And then I could also extend that, right, to my, and own it without having to pay any licenses or anything. But the folks back then didn't really understand that. They were just like, wait a minute, that could be used to compromise us because,
it's not secure, it's not safe.
Yeah, you know the drill, right? Like, yeah.
Well, I mean, there was also like the positioning by all the major software vendors. Like Microsoft is famous, like, open source is a cancer, is kind of like what they answer. Like the Now look at them, like they're totally on the other side.
No, it was right. Like, I mean, it was the Wild Wild West back then. I got to say, compared to today, like the industry is way more. I guess. I mean,
you can't have a software company without open source now.
Right. No. Right. Yeah. Because there's a lot of reasons for that. Right. But at the end of the day, I think, when I was coming up in the government, though, it was pushing it, and it actually kind of led me to, like I said, I jumped around a lot, different agencies, worked in different locations, but mainly in the Northeast here, and then so in 2013, I kind of just felt like, it was time for a change, and I jumped out of the government again. I joined the company here in Philly and was doing a lot of, again, back to systems with them, helping them. But this time, bringing more of my experience and also adopting cloud technology. So now, right, this is like 2013. The cloud is kind of taking off.
Right?
Exactly. Like I came from, the place of, we at one point I was responsible for thousands of servers, like literally racks of servers, right? And now I can go into a web portal and just click a blue button and get the same amount of servers for,
I'll tell you,
really, really quickly.
One of the first things I did as a software like tech industry person is I used to build websites back in the 90s, and I learned that I could get paid once to build a website, but I could get paid every month to host the website. So what I did is I became a hosting company, and I had my own servers, and I would actually go out to co-location facilities and have actual servers. And when virtual machines became a thing, I got a server with a virtual machine on it, and I virtualized my servers and basically was able to reduce my cost by 10x and run virtual machines and resell that to clients. And then now there's cloud, and then there's PaaS, right? It's like not only is
it's sure.
Server, it's like I don't even think about it. I just run a Heroku app, and I don't even have to worry about it. So, the layers and layers and layers of this stuff is really cool.
And
it wasn't always this way. All you newbies, right?
And
for granted,
but. And exactly, like I like to tell these stories, and I thank you for asking me about it, because I know, I've been a manager, I've hired folks, I've fired folks, I've, done all those things. But one of the things I'm starting to kind of see just in my conversations with people is, especially the younger generation, they don't have that, kind of hands-on knowledge and experience, which is a little sad, because they're going to miss out on some of those, not only war stories, but the experience that we had, and it was a frontier.
I spent a lot of time teaching and helping people get into code and stuff. And one of the things that I really try to emphasize is why are things the way they are? If you were to just go to invent the internet, full stop, the World Wide Web, from scratch today, I highly doubt you would do everything exactly the way it is. You'd probably make better design decisions, but the fact of the matter is it's almost like this organic thing. It's like evolved over time. First there was TCP, then there was like so on and so forth. Like then there was HTTP.
Token.
Like, whatever. Like there's like, and it's layered and layered and layered and layered. And this comes to the point in computer programming and being a developer is like abstraction is a super valuable concept. And when I'm teaching people, we're always focused on like, what's the abstraction? What's the best way to do the abstraction? But then also like, why did they do it this way? And more often than not, it's a history lesson, not a technical lesson. It's like, oh, it used to be that like this, and this were this way. And so like we had to take these 5 steps in between to get where we are. And like if we started from scratch, we might not end up where we are. We would have just like done the thing the right way the first time. But like we are where we are because everything is built on the history. Right. And so I really do appreciate that about like, talking to people about coding and like what they do is like, how do you understand how things got to be the way they are?
Right. And so after that, just to wrap up, and I just want to make sure people understand this as well, because I know I know who you are, John. I know Joe as well. Like, we're not besties, but I know you from the industry, and you've always, both of you, always been interested in helping people, achieve what you've achieved, what I've achieved, and that's just awesome, right? But when I left working in Philly, I was always doing, even in the old days in the military, doing kind of developer relations, right? Like encouraging people like yourself, like Joe, anybody who wanted to learn, like, because I always felt like, wow, this was a good opportunity for me. Who else is going to get an education from these like brilliant minds at NASA and in the Air Force? You know what I mean? Like I realized the opportunity I had, and we always have to kind of look out for the folks that don't have those opportunities. So I left, and I wanted to do this full time, and I joined Circle CI to kind of bring that, and they were looking for some talent. And obviously we got along really well. The company's really good. So the point is, I want folks to understand, whether you're starting out or even if you're reinventing yourself. I spent a lot of time myself with folks who just reach out, hey, you've been in this industry a long time. I'm a Java developer. I've been doing it for 20 years. My company now is basically defunding my project, and I need to learn some new tricks, right? Or new skills, I should say. And that's a problem too, right? So not only are you trying to help the younger developers, we're trying to also keep the folks who maybe may get a little complacent, but that happens, right? Life happens, and there's a lot of situations where people need help, and so like young as well. Young is great, right? We have the need to help them, but we also need to help the folks, and it could be those people that actually then are inspired to go and give back. So that's my point, right? Like help, and then help, so return that favor.
Now in your day job, you're a developer evangelist.
Yep.
So what's a developer evangelist? Obviously, I know it is, but like, everybody watching might not know.
So I always tell people, my job is, my role at Circle CI is to engage the community, right? And like, it's not, for me, it's my personal view on it is, it's not limited to just technology, right? I get paid to obviously engage in the technology community, but I'm also there to kind of be a liaison between a grassroots liaison between the developer community and the company. And, Circle CI is a really cool company because they understand that. They understand that they have a product that's geared towards developers, and they need people like myself who can talk the talk and walk the walk, right? As far as being on the same level as these developers, understanding their problems, understanding, the stuff that they're trying to accomplish with tooling. I'm also there to learn how people are using technology. It's a two-sided coin, right? You're there as a more of an altruistic kind of thing. The company's kind of, paying me to be out there helping people advance their skills, learn the product, learn technology. And the other benefit to the company is I get to go out and figure out how people are using technology, right? Learn what they're doing with technology, what they plan on to do with technology, and what they aspire to do with it. And then I bring that information back to our teams so that we can, build very valuable features that can help people achieve what they're trying to achieve with ease within the product, right? So I think every technology company has developer relations teams, but they're not all equal. And you know that, I'm sure, from your own experience, right?
So something I'll say about developer relations, and like, again, this is for the people who are, getting into software engineering or getting into becoming a developer. I didn't know that this was a job. And like, I still think that there are some people out there that don't know that like what you do every day as a developer advocate or a developer evangelist is actually a job. And when I found my first opportunity to do that job, it just like felt like a perfect fit for me. And it's like so different than being an engineer. Like being an engineer, you have like, maybe you have your sprint planning meeting, or you have a backlog of tickets or something. And like, you just like one after the other, just trying to knock down all the things that need to be built, build them, fix bugs, whatever. Whereas like as a developer advocate or doing like developer evangelism, it's much more about people, building relationships, teaching, getting feedback, working with like kind of the engineering team and helping them understand what the users are feeling. And like, honestly, when I heard that was a job, I was just like, oh my God, that's amazing. I definitely want to do it. It's like kind of like, you have to be a programmer to do it, but you don't sit and code all day. You help other people and you work with them. So, just like there's a wide variety of roles in the software space that you can do besides just being a programmer, right? Like,
for sure. I always say you have to cut your teeth, right, on the things you want to do so that you can be credible. Because at the end of the day, this job is about being credible with the people you're engaging with, right? And developers will figure you out. If you're just duping them. That's why they don't have in developer relations most of the time. People are and I don't think you have to be super technical, but I think the most important thing in this business, as far as the developer relations goes, is you have to have a passion for learning, right? And then because you can train yourself, and it's really cool when you can train yourself and do it in conjunction with other people as well, right? So anyway, which goes into the hackathon world.
Okay, so now you're at Circle CI, you're a developer evangelist there. And today, like, really what we want to be talking about is continuous integration and continuous deployment. And like, Circle CI is a company that's like, their entire business revolves around continuous integration and continuous deployment.
So that's what we do.
I think like kind of the first step is like setting up a big picture for people. What is continuous integration and why do we care? Like that's the starting point.
So I think we should talk about the like you just said earlier about abstractions. So let's talk about continuous delivery, because I think if you go up a layer, that's what we're talking about as a concept: continuous delivery. And basically, continuous delivery is just what it sounds like, right? You're continuous delivering. Your code changes, if you really want to put it really.
So, like you were saying earlier, you used to buy software in a box off of a shelf, and that's not continuous delivery. That's like version 3.0 is for sale. We're going to upgrade to 4.0. We're going to put it in a box. We're going to mail it to people. That's not continuous delivery.
That was manual delivery, right?
Yeah, that's literal like UPS.
Right. So well, let's talk about that let's unpack that, because to get right, you would buy this software, right? That's true. Off of, like I said, online. Back, when the internet came online, then you could download it. But back then, you had to buy floppy somewhere at a Babbage's.
I remember installing Windows 98 off of like 100 floppy disks.
Yeah, exactly. Yeah. So like, and nobody, the CDs were brand new back then, right? Like, but right. So you were going and you're buying that software. Now let's say, updates, right? Like you wanted to get an update for that or a new version. Guess what? You're jumping in the car or on the bus and you're going to Babbage's or whatever electronics store that sold it. And you're going to
City,
and drop another $100 on whatever it is that whatever the cost was. So that's how software was actually updated, right? That's how the code changed and you got new releases of software. With continuous delivery, that's kind of like just evolved into automation, right? Like it's now being done through automation. So everything's kind of like a program. It's just running. And continuous delivery is just basically when code changes in a project, it's then automatically, built, compiled, tested, scanned for security, whatever it is you will need to do to that code to make sure that you're producing the best product you can, right? And then releasing that. With continuous delivery, you're setting up all those basically systems, automation to do all that for you. Right. And, that comes in different flavors as far as like maybe not all of the processes are automated, but, the good majority of them are. And that brings obviously some consistency, right, with your processing. And then it also brings velocity, right? So now things are getting done faster because guess what? Machines are doing it, not a manual, person or a person doing it manually. So we're talking about continuous delivery. That's kind of like the top layer abstraction. And then when you dig in to continuous delivery, there's elements, right, within continuous delivery. And that's where continuous integration and continuous deployment come into play.
Okay.
So the common theme is continuous, right? Everything's just flowing. We want the thing to keep moving so that you're not waiting a year, 2 years, 3 years for these updates, right? Like we used to wait back in the day. I mean, it was amazing how they got away with that. Like even with security bugs, right? Like they didn't care. It was like, all right, in 6 months we'll fix it. But with continuous integration now, right? That has a little bit of roots with, and I always do this comparison with agile software development. So back when I started developing software, it was more of what we call a waterfall development process. And that was basically where a project manager would just go to a team of developers and be like, okay, here's literally a binder of all your software requirements, right? Boom. And now we have to open the binder, take out a hunk of whatever the requirements were, and then sit down on paper, whiteboard, chalkboard, whatever it was that we had, and design software, right?
Everything is planned up front rather than like as you go, kind of refining.
Yeah. And you were given the bulk of work, and you had a 3-year deadline, whatever it was, right? The longest project, the deadline I had literally was for like some functionality was they gave me 3 years.
Yeah.
We did it in less, but that was how they rolled back then.
I also think that's like not just the time, but also, maybe government and kind of like very bureaucratic systems like tend to
so
kind of stuff as well, right?
This particular project was, I used to do some consulting on the side as well, and this was a financial institution.
Okay, also bureaucratic financial institution.
Exactly, right.
Okay. So you said continuous delivery is this kind of whole concept of you write some code and it's deployed out or it's delivered to the end user in a fully automated way. You kind of differentiated that there's a continuous integration, continuous deployment. What are those terms, and how do you differentiate them?
So, like I said, the waterfall software development process kind of got replaced for the most part by this agile methodology, where instead of doing the work, kind of in bulky, and by the way, when you're doing waterfall, everything was dependent on something else being completed, right? So like if you had a service that you were writing, but there's another service that needed to be completed before you started writing yours, right? Because you didn't have any way to kind of integrate. When Agile came on the scene, people started realizing like, wait, we don't need to do these things all in blocks, like big hunks of work and make these artificial blocking situations. With Agile, things were broken down into smaller, more manageable hunks of work. And then people were able to, developers were able to take whatever kind of tasks they were probably suited for or wanted to work on and complete them. So, right, instead of writing 30 functions, you were writing one and then focusing only on that thing, getting it really, really tight, and then, adding more functionality or whatever to it. And all the while, when Agile came on the scene as well, then so did kind of the evolution of testing, which was using automation to, bring that into the sphere. So like, there's a lot of things that were changing from, especially when I remember people were testing software with spreadsheets, like paper, like a checklist, and like
kind of like QA style, like
it was
this checklist of all the things. To make sure, like,
yeah.
if I go to this page and I type in my login name and I type in the wrong password, it should not let me in, right? Like
right, and that's where like you have test-driven development, which is really popular for like a way to develop software. I didn't come up in that space, so when that came, and to be honest, I'm still not a big like proponent of it because I'm old school. I came up developing software my way. Where this new generation, which is, I think it's appropriate to definitely teach those things. But there's going to be times like people like myself, it's just really difficult for me to work in that manner, right? Like where you start with something broken and then build it so that you fix it to make it work.
I think there's like definitely a case to be made for, any kind of software development technique. Like you don't want to be dogmatic. Like even
sure, right.
There's like a dogmatic like set of people or like a dogmatic mindset around agile where like everything has to be done by the perfect book. Really, like what works well for your team, right? Like
that's exactly right.
In a balanced way. And like I think the same thing is true about test-driven development. Is like I think it should be taught as a concept that people should understand and like know how to use it. But like if it's not for you, it's not for you. Like I don't think it's like the right way or wrong way to write software. I'll tell you, like my experience with test-driven development was that it like revolutionized the way I write code. Like I became so much better as a software developer when I learned like how to properly do like test-driven development. And it really helped me not with like writing the code so much, but more with like the design of my systems. So
that's right.
How to better make my abstractions between the different objects and how the systems interact with each other. Like because I was writing test-driven like code, I ended up making my code more testable, which meant it was also like less coupled. Right. So
yes, that's right. Yeah, no. And again, like, I agree with you 100%. You got to pick the concepts and the methodologies that best suit your team and the individuals within it, right? Like there's going to be times where, some folks are, you're going to work on teams that are really, really great with test-driven development. Then you're going to work on teams, in the future, maybe that are not so much, that great with test-driven development. Maybe they're just a bunch of hackers that, can get shit done quick, right? And you just have to be able to, I think, adopt, right, and be a very tolerant in those situations to what's going on. And you always bring your own flavor to it as well. That's the beauty of it, right? Is having those diverse kind of experiences and capabilities. But jumping back into continuous integration, so when Agile came on the scene, continuous integration, I think what happened was people were noticing like, all right, we're doing test-driven development, or not test-driven development, but automated testing. There's a pattern here, right? We can actually now automate those tests, right? And as kind of Agile evolved, and if you look at diagrams, I give a talk on this, by the way, but like securing your pipelines, and I start talking about like really quickly the history of all this. But basically, I have a diagram, and it has a lot of circles with arrows versus the waterfall. It's just like, boom, 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 some cascading diagram. So like I always focus in on like there's a center where the Scrum Master lives, and then on the outside there's things happening, and they're all one arrow, right, one direction, but they're all circular, and there's a lot of movement, which I really like, and it's a good diagram that describes kind of what's happening. With continuous integration, same thing, right? So it's just kind of taken all of those Agile concepts and then and marrying them with kind of like new technology, which is I want to say Git. We had version control before, of course. Like I remember using Microsoft Visual SourceSafe at the time. That was pretty badass, right? Like, wow, this is cool. I can version things, and if I make a mistake, I can always. It was hard to kind of go back and get that code and then redeploy it, but you go ahead and fast forward to today, and you have Git, which is obviously right at the core of all these awesome version control platforms now, and you have that technology, and now you can also bring it with continuous integration. You're bringing in leveraging some sort of shared repository, and your development teams can now collaborate a hell of a lot better, right, around code, where we didn't have that before. It was like even in Visual Studio SourceSafe, you could pull in someone's changes, but it wasn't like a branch or anything. You know what I mean? Like it was just a funky way to version control. We got better at it. And yeah, with continuous integration, the core concept there is so I like to say it's basically a way for developers to collaborate around code. And GitHub is a great kind of example of that, right? They had the foresight and said, wow, you know what, we can make this a portal where people can actually do hell of a lot better collaboration around the code, which, believe it or not, helps with a lot of things. Obviously, you're getting a lot of code reviews, you're getting a lot of set of eyes on this stuff, and you're getting it early, right? So people can actually see if I commit code, in 5 minutes later, I can get feedback right away. And that's what kind of continuous integration is at the core. I always tell people it's all about the feedback loop, right? The fastest feedback loop. So you know what the status of your changes are, what your status of your code is immediately, right? As soon as possible, so that you can fix that and then pull another was it sticky off of the sprint board and jump on another piece of code. And that's where we talk about velocity. I always talk about velocity and gaining that speed, right? And imagine if you have a team of 10 developers and they're all writing code efficiently. That's pretty badass, right? We see this all the time with Circle CI. We see new organizations come online and we see their growth too, right? And we in the beginning, it's lots of failed builds and things are just, taking a long time to fix. We don't look at particularly the code itself, but since we run the systems that all this automation is running, we have a lot of metadata around projects. And, we can see when a build goes red generically for, a specific customer. And then we can also see, again, the metadata. We're not looking at the code. We're looking at that metadata that we're running in the platform. So we have a lot of metrics there. And we can see, how long it takes them to get that same build or that same kind of build green, right? Meaning they fixed the problem according to their tests. So yeah, there's a lot of science behind that and numbers. But yeah, continuous integration again is just to optimize the software development process. And the way you do that is there's a couple principles. One of them is committing your code often, right, to a repository or shared repository. And that's where, again, people get eyes on it. They can actually pull your changes into their project, because sometimes our stuff is going to overlap, right? And you have almost like a race condition. Does John deploy his code first and then I pull his in and then work on it? Or do I, do my thing and John, so that is actually external to the system though, right? That's more of a collaboration, increased communication between the teams. So if we both know we're working on things that are going to overlap, we should be having a verbal conversation or a conversation outside of the systems, right? To kind of agree on, hey, John, I'm going to pump this out in the next 2 days. That way you, John, could work on something else. And then, when you're ready to merge my changes. So that's what CI is all about. It's just being more efficient as a software developer and a team, right? Along with adding mechanisms that are consistent in processing, right, all of your what I call workflows or pipelines. So yeah,
I think that there's a really interesting thing. Having been part of some very talented software engineering teams that have a lot of these best practices around writing good tests, doing automated builds, continuous deployment, delivery. When I go and I work on a project on my own on the side as a side project, or I go and I work with, one or two other people, say at a hackathon, I find that I'm at a loss for tools where I'm lacking infrastructure that I'm so used to having in my high performing team, right? Right. This whenever that actually happens to me, I'm like, man, it's such a huge amount of work to set this stuff up. But it makes me think back to the time before I was doing CI. And what I didn't know what I was missing until I had it and I started to rely on it and learn how to use it. To now, I go work on a project, and if there's CI not set up, I won't work on the project until CI is set up. Right? I need CI. It's a crutch for me. I just can't. It's like a game. So I wonder if you have any tips for people who either haven't used CI before, or who maybe used it at work, but have never set it up themselves. how can they think about that, and like how can they overcome the hurdle of like it is time intensive in some cases to like get this stuff running for the first time, and like how do they know it's worth it, and like what are your thoughts on that?
So I'll say this for both people coming onto the scene new, inexperienced, and for folks who, like I described earlier, have been in the industry for a while, but a little complacent or working on things. This advice will apply to basically anybody who's in the industry or trying to get in, whatever. You definitely won't. I mean, you just kind of explained it yourself. You were first unexposed or didn't understand it, and then once you got used to it, you couldn't live without it, right? So it's kind of the same thing when you're getting into this industry. It's kind of an expectation these days because it's being hugely adopted, right? Whether it's Circle CI or some other products, doesn't matter. That automation is not going to go away. So number one, if you're jumping into it, understand the concepts of continuous delivery, continuous integration, continuous deployment. Like literally it doesn't take a long time to truly understand what that is. I try to spend a lot of my time. If you see me give a presentation, I try to give the fundamentals. I don't care if it's like a 5-minute thing, 2 or 3 slides that says, hey, continuous delivery, this is what we do. Because, you can never anticipate the audience's experience levels, right? Mm-hmm. So what I tell people is, understand the concepts of all of those things, right? It's continuous delivery, continuous integration, continuous deployment. I think that applies to pretty much anything in technology, right? Like what are those things trying to solve as a concept before you even jump into any stack or anything? Figure it out because I have this problem where I kind of, have an assumption and then I could spend like weeks and figure out later on, like, wow, I was completely wrong. And if I would have just read the effing manual, right, I would have, or learned about the concept, I would have saved myself a ton of time. Then the light bulb goes on a lot quicker, in my opinion. Once you have that down, right, these are concepts, practices, and principles. Then I would say, jump on a system and then try to implement, the things that you've learned. And one of the things is with CI is all you're really trying to do is like one of the first things you're trying to do is segment your work into chunks, like the agile methodology. So let's talk about that. Let's talk about what do you need to do to get your software kind of tested. You need to compile it, most likely, right? In some, not all cases, but let's say you need to compile. So that we call that building, right? Building an artifact. Then the next thing you want to do is run those automated tests against that code. So that's a segment, right? A job. And I can get into that a little bit later. I can show you what I'm talking about. But then the next step would be maybe you have a security vulnerability scan you need to run on that code, right? Again, with continuous integration, these are all elements of your pipeline, what we call a pipeline. So if you consider continuous delivery, like I said, at the higher level, consider that your pipeline, right? That concept. And then within that pipeline, like any other pipeline, you have segments, right? And basically those are what we call jobs in a CI world. So jobs are just things you want to do. Build is a job. Test is a job, right? Security scan is another job, right? So these are just segments. And then you can go all the way through to like deploying your applications to Kubernetes, right? And then that's where you kind of cross the line into continuous deployment, which if we're going to jump into that in a minute. But CI is all about the code itself, not deploying it, right? Not pushing it to another system, but making sure that you have all the things you need to then kind of set the stage for a deployment, continuous deployment, right? So that's kind of the definition of it. And to get started, again, understanding those concepts and how they kind of all connect is where you then kind of develop. I mean, even when I write pipelines or design pipelines, I still draw it out on a piece of paper or some design tool to kind of get my head around, like, what do I want this thing to do? And it doesn't have to be code, right? It's just blocks that describe the job, and then I can start building it. in code. Now, when you're building these pipelines, always keep in mind that what you're doing is, I mean, building them visually or whatever in your minds, what you're doing is going to make that a reality using tools like Circle CI. The CI tool is just the machinery, the automation behind that, right? So, just always kind of understand. So my advice is understand the concepts that you're going to work with. And then once you get, have a foundational understanding, you have to be a guru at it, but you feel like you understand it, then pick a tool to kind of, start developing some of the stuff that you learned in those tools. And then, you'll see that the automation just kind of marries nicely with the concept, right? So
maybe you want to show some of this stuff if you have.
I can do that. Let me grab. This will be fun. I got a nice DigitalOcean / infrastructure as code and all this good stuff. Let me grab my. Let me grab this project here. I'll share my screen in a minute. I was just doing a cast or a webinar, I think, yesterday. So let me share my screen if I can find all these cool tools to. This streaming stuff's new to me. Well, since I turned that off. Sorry. The screen share, and then screen number 2. All right. So can you see that?
Yep. We can.
Awesome. See it. So this is basically the Circle CI dashboard. Let me plus that up. I think it might be a little bit too small for folks. If that's not working, let's try this. Is that better? All right, might be.
Yeah, you can do even more if you can.
Oh yeah, sure. Is that better? Even bigger. All right. How about that?
Maybe. Yeah, that's fine. We can see it. It kind of that's better. That's good. That way it's not
all right.
Breaking.
Perfect. So if you can see here, right, like I have the pipeline. So the way that Circle CI works, or this system works, I mean, in most modern systems kind of operate, these CI systems operate in this manner. But obviously I work for Circle CI, so I'm going to show you some Circle CI. Now, if you can see here, all these organizations are related to GitHub, right? So here's my my personal GitHub account, which is Punk Data, and we also pull in, like, if you're part of an organization on GitHub. I used to do a hell of a lot of hackathons and used to have tons of fun doing them, but don't have that much time these days, and plus COVID. But I have what I call a hacking crew, and working a lot with primarily college kids and such back in the day. But we had this thing called Data Punks that just hosts a lot of shit on there, especially code and stuff. But that's the organization, and I have this. This code available. By the way, it's open, so like if you want to use it, you can. And as you can see, right, here's the word pipelines. So remember, like I said, if it's continuous, we're talking about continuous delivery. What you're essentially describing is a pipeline of your processes, right, for automation or automating your software builds and software development processes. So if we click into this particular run, you can see here, right, that there's a lot of jobs. Again, right, we broke this down into basically clumped everything together and in a specific grouping of things for a task that you want to accomplish. And as you can see here in this pipeline, or so to speak, we have about 3 jobs. These things are running concurrently, by the way, right? Mm-hmm. So the first one is, let's take a look, usually running tests, right? And you can see all the things that are happening within that job. These are just commands. A lot of these are like spin up environment is the system itself spinning up a runtime to actually run your automation in. So, these things don't happen in the ether. They happen on hardware. It's just that we at Circle CI kind of enable developers to be developers and not worry about the infrastructure. You know what I mean? Like, we handle that. We take care of spinning up Docker containers, machines, whatever, so that you can focus in on your code. And that's what we do here. We just spin up the environment. Then, the system will create some environment variables. These are all like up until about this point, actually this point here where I'm checking out my code, you see? And by the way, this is the pipeline is triggered anytime I change code, right, in that project that Circle CI is kind of monitoring for changes, and then I push it upstream. So once, like with GitHub, once my code changes are pushed into an upstream repo, then this pipeline will kick off and it will run. And it will run, like if you have the same project, John, your branch would run as well separately from mine, right? So that's the way teams kind of keep that velocity going and understanding how the changes are happening. So if we go back one, you could see, or back two, you could see, like, right, I don't have any other branches because it's just me. But if I jumped on some other project, I don't know, like this one, you could see here, there's no branches now, but there were some other branches, that we were working on, me and another person.
Yeah, so you can have this going for each of the branches. Yeah,
exactly. But the thing is, it's an isolation, right? And it isolated to that branch. But you could still be working on it, and anytime any changes are pushed upstream, again, right? The idea here is just to understand, or at least build automation that will help you understand how your software, or bring some consistency into how things are done with that code. So, right, obviously, I'm going to run some tests, and meanwhile, there's no reason that while my tests are running, that I can't do some security scans, right? Like, hey, we're using Sneak here, but right, we can run some security scans. And if right now I have this set to fail, but as you can see, we have some failure, or not failures, but we found some vulnerabilities that are they're high severity. But I'm okay with that, right? Like, it's okay for these demos. But in general, you could actually stop this and it will fail. And when it fails, then you can have like all of the other things outside connected or dependent on this will not occur, right?
Yep.
So so again, right, it's all about thinking about how you're going to create your pipeline and how all of these things are going to interact with one another. So like I said, you have all of these things occurring at the same time. In this case, we call this concurrency, right? Obviously, a parallelism. And as you can see, right, I prefer to try to keep I have a goal for my job. All my jobs, all of these blocks, I want them to complete in less than a minute, right? It's a high standard, I know, and it's probably unrealistic for a lot of, technologies, but it's a goal that I have so that I don't leave it sitting there, right? Because this happens all the time. People get their pipeline working, and then they just never go back to the jobs and ensure that maybe, is this efficient enough, right? Is this something that actually needs to still be run? You get those unit tests.
Let's talk about how to make our pipelines faster. So what kinds of things can we do to make our overall like build pipeline finish in less time?
Yeah, so there's a couple
and
factors.
Also, why do we care?
Yeah, no, sure. Well, why? Because you want to get stuff done quicker, right? And then have either free time to focus in on something else, or maybe you just want to take a break and chill.
Yeah.
And,
the thing you said before about the feedback loop, it's like you get the feedback faster if your pipeline finishes faster.
Yeah, exactly. That's
if the pipeline takes 10 minutes, then it's a 10-minute wait. And that famous like XKCD comic, it's like, oh, my code's compiling, right? Like I could go goof off. But like if your code takes like 5 minutes to build, it's to run the pipeline, it's effectively the same situation as you're just sitting around waiting.
So that's right. And eventually going to get there. But basically, right, the fast feedback loop of knowing like this stuff happens as soon as possible, right? So that you're getting confirmation based off of your own kind of criteria if things are running as planned. So number one, to make it efficient, you want to always keep a mindset, like I said, right? Keep things very have a standard of like how long these things these pipelines should be. like I said, I go to the extreme of like less than 1 minute, but realistically, that's not going to happen, right? And one of the reasons is sometimes you're connecting to DigitalOcean or some third-party infrastructure that you don't have any control over. So if you're creating a Kubernetes cluster, it's going to take you however long it takes them to do, right? So there's a dependency there, which is fine. It's acceptable. But keep an eye on it. Maybe there's some new version of their software or some new way to do it, right? Optimize that. The other thing that factors into it is also understanding, well, it kind of leans into the DigitalOcean Kubernetes creation, is understanding the dependencies and the technologies of those dependencies, right? And what I mean by that is Docker containers, building Docker containers. There's, believe it or not, there's an actual optimization to that process. A lot of developers don't really understand it because if you understand like the nature of Docker, they actually have caching layers, right, inside of the build. So when you build a Docker file, which I can show real quick, I do have one that I could probably show. Here's a good example, and it's an easy one. But basically, right, here's a Docker file, and all this does is basically tells my system, or my it tells the system how to build a Docker image for me. And this is a really simple one, and it's a Node application. But one of the things that happens is people copy, like if you have this copy command and all it's doing is copying code into the working directory, right? So that it's included in your image. And then when you spawn a container, all those things kind of occur, or the files are there. But most people put all of this copy stuff up front and then they install NPM, or the dependencies, right? And if they do that, at the end, then all those like if you make a change to your code, right, it's going to always install. Actually, this is a good example of how not to do it, by the way. I just realized that. Yeah. So you want this. See, good example. This is an old version. I didn't realize it. But so what you want to do is I'm saying this backwards, put the copy stuff, all the files and stuff that change up front. Why is that? All right. That's your thing. Let me grab that again. So what's happening here is, we want basically to push that there. This is an optimized Docker. See, look at that. I just gave you like a real world example. So basically, right, if I change these files, now my Docker, the only layer will change is this the image, right? And then these installations of npm install won't change, all right? Like the dependencies won't change. The cache will remain the same. So basically things like that, right? Like you want to take and optimize things that you're using first. So like there's layers of optimization, and understanding how things are working in your code will help with those optimizations, right? Because you're going to build a Docker image in your pipeline, which I do at some point here. So this job is called scan push Docker image. So like I did static analysis for vulnerabilities on the application and its dependencies on the previous scan job. This one is actually scanning my Docker image. But as you can see here, right, with all these steps, I have I'm building a Docker image. And here's that Docker file, the results of what was happening, right? And you can see here, all these steps are a Docker layer cache. If that makes sense.
Yep.
So, right, if you don't have to build or compile anything that hasn't changed, then that's quick, right? That's super fast compared to having to do all that. And then finally, I'm running a scan on the actual Docker image I just built, and you can see that the output is a lot different. There's a lot of problems with this, right? With this image, because it's an older image, to be fair. But basically they give you this tool gives you a little bit of insight into remediation, right? Like, oh, you should probably use this image because it has less high severities. Anyway, it's just like patching. Since we're working in an ephemeral, immutable world, that's how this stuff happens. So to make it faster, so number one, understand the technology, understand kind of your processes and your flows within those technologies. And the other bit is having a sense of logic to it, right? So You know, like I said, I know that I'm comfortable with running all of these things in parallel. Like I see a lot of people build a dependency on tests, right? Like they won't create a Kubernetes cluster unless their tests are run and pass. You know what I mean? Like they'll just move this into like a blocking. And I consider anytime you see these lines working like this, I consider that blocking, right? Like I'm always obsessed with trying to, what else can I do in this row of after the deployment in parallel? Obviously, if I'm deploying my application here to Kubernetes, then I want to run a smoke test. So basically what I'm doing here is testing my deployment. Right. And if you look in this, all I'm doing is running a quick test, like, am I getting a 200 response? And then it's a static website. So I use this for demos. Like I'm testing for some text, right? Like, is this working in the body? Is this exists in the body? And it passes. And I use this example to kind of tell people like, hey, you can basically test not only the application, build whatever scanning capability or vulnerability scans you need to do into your pipeline, but you can also package it up and then test that release in the environment you're targeting. In this case, I'm targeting Kubernetes, right? A Docker image, Kubernetes, and I'm building out the Kubernetes cluster live with every build, and then deploying that application, and then I'm running like a quick smoke test, right? And then afterwards, I can destroy that. Right, like this is a manual step, but normally I just have like if it passes, then it just destroys the cluster, and then your release teams or management and teams know, they have a lot more confidence in that application, and like wow, this thing ran in Kubernetes, so that's kind of like a check off, right? Like done. Yeah. Now there's more comprehensive tests like function was it functional testing, integration testing. Those are more involved. They take a lot more time.
Would you say that like the CI tool has anything? Is it the CI tool's job, or is it your testing framework's job to handle like parallelizing executing your tests? So like I've worked on apps where the test suite can be a 30-minute test suite run, and like almost never run the test suite locally, or even longer. Right. Like especially for like native applications, talking about like iOS development or something like those things can take a really long time to build and run. But if you run them in CI, you're able to parallelize like a huge amount and make it so much faster. So like how do you approach that here?
So one other piece to help with like making things faster, is the actual hardware or resource class or compute node you're running to do this stuff. Like if you look here, I know there's some details that there used to be. We're kind of upgrading the UI. So let me see, maybe there is details about where this is running, and it's usually like what I mean by that is the capacity on the node, right? So we call those resource classes. And what happens there is obviously, right, you're running in some virtual machine somewhere in some cloud, and Circle CI facilitates all that for you. But what you can do is have a key or change the resource class. You can tell the CI tool like run this in a extra large Amazon instance, right?
Or like a GPU optimized.
Exactly. Yes. One of our customers does that, right? We had to add GPU. We actually added for them. We were working on that anyway, but we kind of prioritize that. So we have that support, and we have different levels of what we call resource classes. So that's another way to kind of optimize, right? So if you're running your stuff on a medium sized machine and it's just taking 20 minutes, I've seen where people just up the ante and go for that running that stuff on those bigger nodes, and it gets done way faster, right? But the other thing I wanted to say, though, to your point about when you're running tests and using the actual technology, that's why I said earlier, understand the technologies that you're using to optimize as well, right? Like I showed you with Docker, if you don't build your images properly in the right order, you become inefficient, right? Like it just attacks on time if your cache is not working for you, because you just don't understand how to organize that. Same thing with like stacks, right? Like if you have like Java is a good one, Scala is another one. You can actually set your testing applications to say, hey, you know what, run all these tests, as and in a multi-threaded kind of way, right? So concurrently, and that's test design, right? That has nothing to do with the CI tool itself, right? That's just understanding the capabilities of the technology that you're building code on. I see it. I used to do this all the time. Like, why are you just running all of this master suite on a single thread? Like, what's going on here? Like, you know, and a couple changes and we had these things running. So like a test that would take an hour, knocked it down to 6 minutes, you know, something. And it was a very comprehensive test, but like, that's how, you know, and again, right, you're setting up blocks as well, similar to what you're seeing here. There's some testing suites that do the same thing.
Okay.
So,
so what else do you think is important to talk about, you know, kind of before we start to wrap up?
Yeah. So, when it comes to CI/CD, you know, I want to get the message out, and I talk to my team all the time about this, especially with the DevRel folks. Like, there's more people that don't understand what this is than there are that do, and the ones that do, you know, I don't have to worry about them. They know what's going on. They have more advanced needs. So, like, you know, if you're looking at this stuff and you're confused, it's okay, right? Like that's totally fine. The other thing I want to say with CD is, and this is really important, failure is good, right? Like at Circle CI, you know, I love to see these red builds. Look at, I mean, you can see what I'm doing here, but you know, this is great. Like, and the reason why a lot of people look at me, you know, a little cross-eyed, like when I say that, but think about it. It's telling you that you have a problem, and wouldn't you rather catch that problem early on before it goes down the range, right?
Before production, right?
Exactly. So, like, look at this, right? Like, I have some weird issue, and this was because that was another problem with this build here. I was working on it yesterday, it wasn't working, and I realized that I had it was all jacked up, right? Like, this just was. And I was like, but I cut and pasted it from another thing. So like, these are the kind of things, right, that will help you catch those mistakes, even though, like, again, right, it works on your laptop, but it was working on my local environment. And when I pushed it to CI, I was like, whoa, Angel, this is all jacked up, right? So it kind of homogenizes the environment too, so that, you know what I mean? Like, if you build this into a Docker image, it should work.
This is what I was saying before, like, about like, I feel like CI and like automated builds and all this stuff are like a crutch for me. I could never go back to working without it, because literally when I work, I'll start a new branch, I'll write some code on it, I'll push it up to GitHub, and it'll immediately run, and I'll see a failure. And I'm like, okay, cool, I know it's going to fail. And like, once it starts passing, I'm like, okay, I guess I can just merge this now. And I merge it, and it's deployed to production, and it's like done. And it's like, I totally agree that the failure is good, because you're like, if you have a good test suite, you have a good like set up and good, like, you know, pipeline and all the different steps, like, you know, there's never going to be a mistake in the deployment. Like, you're never going to accidentally like drop the database or like do the wrong thing.
Right.
It's all like codified, and there's no margin for error other than when you make the thing for the first time, right? It's not like you're like typing a specific command every time and like you might mistype, like have a typo. So I really like that about CI and about like all this stuff. Is it just like really, really standardized? And then the other thing is I wanted to add about this is like, you know, sometimes you'll like start from like a base branch and you'll do some work, and like somebody else will merge something in before you update. And so the way I set up my pipelines is it actually runs two builds. It runs one build, which is my branch, which is all the code to my branch. And then it runs an integration build, which is if you merge this into master or into like the main line of development or whatever branch you're targeting, it will run the build on the resulting merge first.
That's
and tell you if it'll work or not. And then if it works, it will let you do the merge. Right? Like, it doesn't actually.
And
I don't know what you call that. That's something that like
so I can show you.
And I had no idea what that meant. And then once I understood it, I was like, oh my goodness. I was like, there's a huge like blind spot for me.
Yeah, so the way it works is I'll just quickly go show some code. So by the way, everything in Circle CI is built into this or defined in this config.yaml file. So as you can see, remember that scan app, scan, push Docker images. These are all jobs. And inside, if you want to take a look, right, this is what it is. It's just some YAML and, specific to Circle CI. This is what we call an executor, the runtime that we're running. If it's a Docker executor, I'm running this code in Docker, then I need to give it an image, right, so that it can run. And we're using the node image. And then, of course, right, like, look, there's that sudo install, right? And then I'm scanning the application files here. Here's an orb, right, a call to do that, which is basically packaged code. So like almost like an include statement of functionality that the vendor has built. Because we have the same customers. And then, but what you're talking about is, so you have these jobs. So here's a list of jobs, right? And those are the things you want to accomplish. And then workflows in Circle CI's universe is basically how you orchestrate the jobs, right? So you see here, first thing, this is how you run in parallel. So by default, Circle CI will run your jobs in parallel. You see, remember those 4 things that ran? And the way you set up a dependency is by the next job was going to be deployed to Kubernetes. And then you add a requires key. And then you say, hey, you can't deploy unless these 2 things pass, right? So that's kind of like by its own like native nature, Circle CI is actually running everything concurrently, and you have to build those dependencies, and that's kind of like where workflows comes into play. And then you can get it even fancier inside of here, and to kind of address what you were talking about, we could actually set up what we call filters and say only do this particular job on a specific branch, right? Or even you could read tags, right? So it's like a regex, if you tag it with a specific kind of standard, you can set basically limits on when exceptions to when to run these things, which we call filters. So that's when you get like, you could actually do that. Hey, don't merge any of this shit until all of my stuff is done, right? Like, and every time a transaction occurs in GitHub on code, like if you open a pull request, we will actually, no, that's not true. If you open a pull request, we go with the latest build for that commit. And then, we kind of integrated that into the GitHub view so that you could do that. You could also, once you merge into master, then that pipeline will run again. So like you could have a workflow that just works only when you merge to master. You know what I mean? Like you could skip even all the testing bits, right? Like if you wanted to, and say, hey, only run these things. So that
would be like only your deployment steps run when merged into the default branch.
Right. Yep. And there's a lot of things. I mean, this is not an easy. I don't want to say by any means that this is an easy kind of concept to grasp, especially initially. But once you get it, like you understand what these things are doing, the tools are doing, then you start to, as a developer, realize that, wow, I'm in control here, right? I don't have to wait. Back in the day, I had to wait weeks for an operations guy or person to come and like deploy my code and then tell me like I made changes. And 3 weeks later, like, yeah, it's broken. And here's a floppy with the logs. And I'm pretty much debugging in the blind. You know what I mean? So like, that's the whole point of Circle CI is like, you don't need that ops team. You don't need a security team to kind of get that first initial, development done. You can control that. And again, that kind of leans into that DevOps culture, right? Where developers are not alone in this. You also have operations, and the fact that it's in code, people can just go in and pull in changes. An operator, even security, right? They can go, you know what, this scan is not good enough. Like we need to do better, and they don't have to interact with the developer, right? They can actually make the changes there, and the developer can then capture that. You know what I mean? In their code without having to do much. So yeah, there's a lot of benefits to it, but it's centered around collaboration, right? But a few concepts: collaboration, the feedback loops, and then the automation, right? Making the things do what they need to do. So,
well, excellent. Well, I think we're just about at time for today. But this has been really awesome. Thank you for walking us through this continuous delivery, kind of elaborating on the CI/CD, and also about like talking about your career and your story.
Oh no, yeah,
I think it's really valuable just to see like how that stuff can happen, and we don't always set out with like the end goal in mind. We don't know what it's going to be when we start.
Yeah, no, for sure. But I like I said, I started with basic, and honestly, I went to community school. That was one of the reasons why I didn't have the wherewithal to continue on. So I joined the military to kind of help with that. But yeah, the few classes I took, Visual Basic was one of them. That's kind of the only real official class I ever took that I paid for. Yeah. And I already knew all this stuff. So when I took that class, I was like, well, I didn't really learn anything.
I could be teaching this class.
And, it just kind of opened my eyes to the fact that, you know what, I have a passion for this. And like anything, if you have a passion, you can train yourself, right? And especially now with all the resources and
it's a totally different world now.
Yeah,
like, of like educational content and like self-starting and like tutorials is like absurd. I was getting into coding, and like I was reading a book. Like literally, it was the only way I could learn how to code was like from a book. It's like there were no video tutorials.
Me and my friends were nicking magazines, right? Like, but we were suckers because we always brought them back. We felt guilty, It was harder to, believe it or not, it's harder to sneak stolen things back into stores than it was to get it out. But we were always trying to be, we were like, all right, it's a necessity. We got to do it. But we feel guilty to bring it back.
Yeah.
But thank you for having me. I really appreciate it.
And we'd love to have you back again sometime. And,
always down, John.
Also, like you're very welcome. I think you've got a lot to share. If you want to sign up on the website, come check us out. We're pairing people up with coaches and stuff. If you want to help anybody out, that's cool. But yeah, also I guess just to wrap things up, this has been an awesome live, kind of like experience. We're here to help developers advance their careers at every level, whether you're getting into software for the first time or you already have some experience and you're trying to make the next step in your career, getting a promotion, changing jobs, whatnot. And the way that we do that is by focusing on real world stuff with real developers. So people like Angel coming on board today and just talking about your experience is really valuable, and I hope it helps a lot of people out. So thank you again, Angel. Have a great evening.
Thank you, John.
Talk to you soon.
I cut Angel off too early. I always do it. I will never find an elegant way to do that transition. Thank you, Angel and John. That was awesome. I hope that was useful to everyone watching in the chat. Before you leave, stay where you are. Let me run through our schedule for the rest of the week. You can find that schedule at twitch.tv raised_schedule. We still have 6 shows to go before Hacktoberfest is wrapped up. We will be back after Hacktoberfest. We don't know exactly what days yet, but we'll make sure that lands on the schedule when we are. So let me give you a preview of everything we've got going on before the end of the week. Let me just get one moment to bring that calendar up. So tomorrow morning, we have... Tomorrow morning, we have Guanluca from Equinix Metal. I've just actually seen that Equinix Metal are at a conference tomorrow, so I hope Guanluca is... we're not taking him away from anything. But Guanluca is on... so that show tomorrow is going to be what we call More Than Code, where we look at ways you can contribute to projects that aren't purely code-based. And that show tomorrow is going to be all about Guanluca's work on the special interest group for releases at Kubernetes. So Guanluca works on releasing Kubernetes, making sure that releases of Kubernetes, go out of all the things that they should contain, go out to a good quality, they're working. And Guanluca works on that release process, and so we'll be talking to us about that tomorrow and helping show you how you can apply that to projects that you care about and contribute to projects in a different way than code. Next up is Nathaniel from Twilio. Nathaniel's a developer advocate developer evangelist, for Twilio in London, and we're going to be playing our favorite game, the Old Code game, where a guest brings some old code that they worked on in years past, and we talk about how they've grown and what they would do differently in that code today. So Nathaniel's going to be bringing us the first JavaScript application that he ever wrote, and we're going to be reviewing it. He wrote that in university, and he's been in the industry for a little while now. He's been at Twilio doing lots of cool demos and sample apps. So we're going to be talking about that code and what he'd do differently today. And then our last show of the day tomorrow, John's back again hosting Sam Lanning. Sam Lanning is at the UN. He used to be at a company called Semel, who write a query language for querying security aspects of code, like a security tool. They got acquired by GitHub. We worked with him briefly. I worked with them briefly, sorry. And then Sam is now at the UN, so we're going to hear all about that. But most importantly, we're doing the old code game again with Sam, but with something a bit different. Sam is bringing us a project called Synesthesia, which is a controller for LED strip lights and music meant for interactive installations at festivals. So the idea, like, hey, you've got some interactive art installation that's reacting to light, that's reacting to sound and producing different light patterns based on that sound. That's what Synesthesia is. Super cool project, and John and Sam are going to be cracking that open tomorrow in our last show of Thursday. And then Friday, our last Hacktoberfest shows. Going to be an emotional day, very special day, a day full of reflection and looking back on cool stuff. We're starting off with Nicholas Carrigan, which I'm super excited about. Nicholas has been hanging out with us in the chat all month, and so we're getting him on the show to look at some of his open source projects and some of the things he's contributed to this Hacktoberfest. Then we've got Eddie. Eddie's an open source advocate who has an amazing YouTube channel. He helps people get into open source and various aspects of contributing to open source. He's been really busy this Hacktoberfest. We had him on at the beginning of the month to talk about his plans for Hacktoberfest, his tips for getting involved for Hacktoberfest, and we're going to have him back for a bit of a reflection, a bit of a look back, what went well, what has he been working on, that kind of thing. And then our last show is very exciting. We have Chris Ewald, who's a developer and a coach here at Raise.dev. Raise.dev worked on the Hacktoberfest app, the app that powers Hacktoberfest last year with DigitalOcean, and gave that app up to Matt Cowley, who we've had on the show several times now, including this morning, who's now the maintainer of it. So we've got Chris and Matt coming back together to break open the app, talk about, like, have a little old maintainer, new maintainer discussion, talk about what the situation was when Chris led the development of that app, what's changed now, what they would do differently in the future, what's been changed in the year since Chris had his hands on it, all these good things. That's going to be super fun. And Matt, we were talking to Matt about that a little bit this morning in his stream about CDN.js, and I know that he has some things he wants to talk to Chris about and ask how these things came about, so that's going to be super great. And that's the end of our Hacktoberfest stream. I couldn't think of a better way for us to end this month of Hacktoberfest than beating up the Hacktoberfest app and talking about how it was built and how it could be made better in the future. So that is all for our schedule. We will be live again tomorrow, as I said, with the first show of the day. If you want to keep track of that schedule, you can find it at the link below, or you can follow us here on Twitch. You can hit the love heart, hit the bell. You can also follow us on Twitter at RaiseDevs, where we tweet an hour before every show, so there's no way you can miss any of these shows. And other than that, that's it for me today, as I get ready to leave you all and hopefully see you tomorrow. Just a final reminder, if you're not already signed up for Raise.dev, that we are here to help you level up your developer career with the help of expert coaches. As John said, we are folks who are really keen on helping you get the experience you need to make that next jump in your career, and you can sign up completely for free at Raise.dev whilst you're in early access. So have a wonderful night or day or morning wherever you are in the world. We will see you at the next stream, and thank you so much for joining us.